Okay, guys, for this one, the equation was y equals x minus 3. So whatever x value is given you, you need to subtract 3 from it. That will then give you the y value, right? So if x is 0, it's 0 minus 3, which is negative. If x is 1, 1 minus 3 is a negative 2. If x is 2, 2 minus 3 is negative 1, right? Then those three values, I suppose, give you 3 points, right? 0, negative 3. Just check out that that is your point 0, negative 3. So it's 0 on the x-axis. Now they actually didn't draw the axes properly because they're supposed to be a 0 there, right? So 0 on the x-axis, but negative 3 on the y-axis. The next one was 1 on the x-axis, negative 2 on the y-axis. And then the last point was 2 on the x-axis, so 2 is over there, negative 1 on the y-axis. And like I said to you guys on the Thursday, just draw a line using a ruler and make sure that you extend the line past your last point and put arrows on it. Are there any questions on that one? Right, C. Okay, C was a bit more complicated. It wasn't just your x value minus something or plus something. Now you have to multiply your x value by 2 and then add 1. Alright, so if x is 0, what's 2 times 0? 0 plus 1 is 1. Okay, so that is the point 0, 1, guys, which is over there. 0 on the x-axis and 1 on the y-axis. Okay, if x is 1, 2 times 1 is 2 plus 1 is then 3. Okay, and then you do the same with 2. 2 times 2 is 4 plus 1 is 5. Alright, so just take a look there, guys. Those are the 3 points that you have to plot. Yeah. Oh, yeah. Yeah, someone offered you this. Alright, so we find our C. Any questions? Alright, D, the last one was that equation 3x plus 4. So whatever x value that gives you, you multiply that by 3 and then you add 4. And you have any questions on those ones? Okay, I'm going to hand out another worksheet. Before you start working on this worksheet, I'm going to show you guys some videos. Alright guys, just stick that in please. We're gonna look at some videos quickly. I just need to see if I can get everything sorted here. Where's this table? That's quite obvious. You guys game. So I don't have to carry on with answers now. Alright, guys, I'm going to show you a few videos. I'm not sure how many we'll see. There are loads here. Basically, if you're looking at this worksheet, it says real life graphs, right? So we need to be able to take a real life situation and put it on a graph, all right? Using not necessarily specific values. If you look at the little graph that they've given you on the pictures, or on this worksheet, have they actually plotted points? Are there any values? Are there any numbers on any of these graphs? No, right? But if we look at the first one, we can see that we have speed on the one and time on the other axis, and then we can see that they're both increasing. See if we can look at that, right? If you're looking at speed, can we see that from the start? The speed is going up, it's actually moving up, right? That's what really trying to do. The time as well, time is also moving forward. Okay, so this is difficult if you haven't looked at examples, which is why I'm going to show you some examples now. I'm not sure if there is sound and it's also not connecting properly, so we're going to have to, it's probably going to look a bit awkward. There isn't going to be sound with this, but basically they literally have like a man walking across a bridge and then they show how that relates to a graph, for example. All right, so we're going to look at a few of them. There are a few different ones. Okay, so the first one is elevation versus time. So they're going to, on the x-axis, they're working with time. All right, just looking at how, and at what I'm going to show you seconds, right? We're going to show it now, and it's what we're doing as well. So are we noticing that he's starting at a certain height and then he's moving up, right? Elevation is what he's talking about. All right, so again, he's starting there, and starting, so time is moving on, right? So he is moving up. And then at a certain point, you know, do we see that he stops? So there his elevation is constant for a while, right? He doesn't move up or down. And now at 7 seconds, he starts moving. What's happening to his elevation? Sorry? Down. So can we see already how this graph is going to look, right? Up and then plus 2 bits and then down. Okay. So that's what we're going to show now on this graph. They have specific values, all right? So they're showing that his elevation is around 65 at the beginning. Okay, so around. And then with the bridge, that's where you stand in front. And then they do their job. Right, does that make sense, guys? And let's look at another one. This is another elevation versus time thing. So again, we need to think of moving up or down, right? So time, and then elevation of the ground is on the other axis. Okay, so there is moving down the stairs again, on the little landing, down the stairs again. All right, and for some time there, did we notice at the end it was the same elevation, right? On the ground, wasn't it? Okay, so guys, what's happening there for the first couple of seconds? What do you think? It's flat, hey, because he's walking from the back. I don't know if you could see there at the back, but he was walking from the back of that kind of corridor there to the front. So in terms of elevation, he is moving, but his elevation is staying the same for the first bit, right? And now he's going to go down some stairs, so elevation is going to go down. Okay, what's happening there? Flat, good. Down again. Gonna go flat, there we go. It's gonna be flat there again, then again down further, and then for that last bit, it's flat again. Okay, just in terms of his elevation as time is passing. So let's see how they draw that. All right, that is what we predicted. Hey, he's going down again, flat again, down, and then there, where he's actually on the ground, do we understand why it's at 0? Oh, did he go up again a little bit? Looks like it. Oh, on the page. All right, guys. Are we kind of seeing how this works? Obviously, it's easier seeing it than doing it, but we are going to practice now. Another elevation versus time one. They're not all elevation versus time. We will look at some others. Okay, so he's going down there, down those stairs. Taking a little break. Going down again. There's the elevation stays the same, right? Okay. I think this is probably a teacher that made this like workshop. All right, there's going down. And there, that last part is going to be flat, right? Just like that. You're like, oh no, it's recording. Okay, let's take a look. Okay, so down. And guys, do we notice that it's quite steep, hey? The actual like going down, right? And there he's taking a break, drinking some water, going down again, and there he is on the floor for that last bit. All right, I quickly just want to look at, okay, let's see, I'm going to skip ahead, let's do number 6, let's see what this one is. Hey, Jesus. Okay, let's see what happens here. Oh no, is he going to hit his finger? Okay, so I mean, lots of time is passing, hey? No pain. Are we seeing that? Oh, that's great acting. He's like, you think with the hammer. It's not very convincing, but okay. All right, so there, no pain, no pain. Do we see that? Okay, he's just putting the nails in and then. No, he has nails in his mouth that he's taking off. Okay, shame. Let's look at number 8. Okay, speed versus time, guys. This is an interesting one. All right, speed versus time. And this is actually, if you're looking at your real life graphs worksheet, the first 4 graphs are all speed versus time. All right, so this is the kind of example that we are going to work on now. Now, obviously, they're talking about miles per hour. It doesn't really matter. Okay, so time is passing, right? Okay, he's running, doing a little jog. It looks like it's the same speed, hey? It doesn't look like he's running faster or slower, really. You guys agree? Looks like he's going at a constant speed, right? Okay, let's see what the graph looks like. What's happening there, guys? You see that it's staying the same. What does that mean? He's running at the same speed, which is what, like 3 point something miles per hour throughout the whole time. Right, do we notice that? So guys, that's also possible. Can we focus, please? What we call this is a constant graph or constant speed, right? Because its speed is staying the same. It's staying at a constant value. Let's look at 9. Elevation versus time. I think it's the same run that he's doing, but now we're looking at a different. Guys, you're not focusing, hey? You're going to do this work now afterwards, and then I'm not going to answer your question. Thank you. Elevation, is he going up? It does look like the road has a bit of a slope up, hey? And there, maybe down a bit there. Yeah, he is going down towards the end. Okay, let's skip this review at half speed thing. Okay, so elevation going up. Then there it looks quite flat, all right, for a while. And then after he goes past that last corner, going up again. Oh, I thought he was going down. But yeah, I suppose he's going up a bit. Yeah. It would do like a spike, yes. Mm. Say again? No, well, he would still be at the same elevation. So it would stay, the same. Okay, let's just quickly look at what 10 is. Distance versus time. This is the last one, guys. Then we're going to do some questions. Okay, so again, we're looking at time. And now we're looking at distance along the road. What's happening to the distance that he's running, guys? Do we agree that it's increasing, hey? He's going further and further as he's running. So what do we think that graph is going to look like? Let's predict it. What do we think? As time is passing, his distance is also going up. What do we think? Okay. It's going to go up, right? The distance is going to increase. Okay, let's take a look at what this graph looks like. Thank you, Toba. Are you looking at the board? Doesn't look like it to me. Do we see that, guys? As the time is passing, the distance is, or as the time is increasing, rather, the distance is also increasing. Do we see that? That is kind of what our first graph looks like, right? But the first graph is speed versus time. So let's take a look at what's happening with these ones that we're going to do. So they're saying copy each graph into your book. You don't have to do that, guys. That's going to take a long time. You can just refer to the graph here. So they're saying for each question, write the statement that describes the graph base either side, on the side, I suppose. So guys, what you're going to do is, do we notice that there are 4 graphs and then 3 descriptions, right? I want you please to match each description to a graph, but there's one description that's missing. Okay, thank you. So you're going to have to try and match it up. And then the one that's missing, I want you to try and write a description for what is actually happening for that one as well. All right, so I suggest that you do this in your books. But for the first one, you can say I suppose. All right, so this is, no, number 1. Okay, so this is number 1A. All right, that's what you're going to write to refer to the first block. 1A. Then you're going to choose one of these three. Now guys, let's just look at what's happening here. Do we see that it's going up, right? Time and speed. So what does that mean? When I look at this, I'm saying as time is passing or increasing, the speed is also increasing. All right. So what do we think, guys? A car drives at a steady speed. A car gets faster and faster, so the car is accelerating. Or a car gets slower and slower, so the car is braking. You guys think one of those three descriptions go with this graph? What's actually happening to the speed? It's going up, okay? So is that at a steady speed? If it's going up, if the speed is increasing, right? That means that the car gets faster and faster. So for 1A, I would write a car gets faster and faster. Right. Then you look at B, you try and figure out what's happening here. Guys, it's useful to actually look at the graph and first figure out what's happening and then look for one that fits. Okay, if there isn't, you're going to have to write a description in words. I would like you to do the next two sections as well. So it's the exact same thing, guys. They've given you graphs and descriptions. You must match them up. And for the description that is missing, or the description that's missing, you must write your own thing registered. Okay, for 2 and 3. Some of these are quite difficult, so don't feel bad if you are struggling. All right, it does take a while to kind of wrap your mind around this. Let's see if you can manage it.